Everyone for joining this session. This is way beyond expected. I was told that there may be 20, 30 audience, but apparently we have 100, more than 100 in the room. My name is Dakuo Wang. I'm currently associate professor at Northeastern University. I'm also a visiting scholar at Amazon.com. So if you are interested in job opportunities, PhD opportunities, do talk with me. My team at Amazon is hiring. My team at Northeastern is also hiring. Okay. So today's talk title is From Human-Human Collaboration to Human-AI Collaboration. First of all, thank ACM for sponsoring this event, and please consider joining it. This is I'm part of this distinguished speaker series, which means ACM is paying for the food, the drink, and if there's any travel involved, they will also pay partially the travel. So do consider to join ACM and thank them for the generous support. As the host, Katif has already nicely introduced, before joining Northeastern, I spent some time at IBM Research, Stanford HAI, and before that, I got my PhD from UC Irvine. I consider my research at the intersection of human-computer interaction, artificial intelligence, and also team collaboration. So the central piece of today's talk is a human-centered AI. But what is human-centered AI? There's no unified definition, but if you ask different researchers or practitioners, they may give you different opinions. In my opinion, this is very broadly defined. Human-centered AI is no matter whether you are designing user interface, whether you are building algorithm, whether you are building a system, as long as you are considering human value, considering the potential future use by human, by the real world scenario, that's a human-centered AI. In contrary, right, if you are designing a system or algorithm simply to show off that you know some better or advanced technology, you are only competing in those toy examples or benchmark data sets for a higher performance, then that's not human-centered AI, that's AI-centered AI. So that's my general definition of this term. What if a real-world system doesn't consider themselves as human-centered, but rather go with the AI-centered AI direction? We have seen many of these failure examples in the real world. So the most familiar one to me is the IBM Watson Health case. So IBM Watson Health is one of such great idea that they want to use AI algorithm, deep learning-based AI algorithm to help clinicians to make decision, right? So AI say what the disease is, and the doctors make a human AI decision making together. Starting 2016, right, IBM invested billions of dollars money and organized the entire industry sector. Thousands of people got hired. And then roughly 2019, 2020, right, IBM decided that's a really, that business is not going anywhere, and lots of scandal and media coverage. And then they decided to lay off thousands of people overnight. Right? That's thousands of families losing their income and billions of dollars wasted in that investment. Why is that? So I'm not allowed to share what happened behind the IBM case, but in my research activity, I invested some of these similar systems in a different context in China. So this is typically called AI-CDSS system, AI-based clinical decision support system. How it looks like, this is a very typical. So nowadays, around the world, the hospitals typically will have a EHR system, electrical health record system, that doctors are using to record what's the patient's symptom, sync up with the lab test, all those things. And then they record what their decision is in these systems. Right? So the AI-CTS system will be built and implemented as a plugin into the existing system, the EHR system, for a UI familiarity kind of purpose, so that doctors can be more familiar with this system. And then in the system, it will the AI system will plugin will be proposing, I believe the highest confident or highest possibility is this particular diagnosis, option 1, AMI, and then there are 2 additional kind of like suggestions. It also provides this percentage, which is a confidence score to indicate how certain that the AI algorithm is, right? You also notice some of these buttons or these features are highlighted. So these are aligned with the so-called best practice of explainable AI design, or the XAI design, to give user not only the final top suggestion, but also top 3 suggestions, candidate suggestion, as well as giving them some explanation. Typically, it's calculated based on feature importance score, the highest feature importance score. So this particular feature is extracted from the input data, right? And everything that the designer, the developer did was following best guideline, best practice and human-centered AI guideline. But still, after 5-6 months of implementation and deployment, we went in to interview those clinicians who were using the system. Roughly, there were 1,500 clinicians were using it every day. We interviewed 20 of them from 6 different clinics. All of them were telling us that they are abandoning the system. They don't find it useful. They don't want to use it. They find it annoying. So why is that? Why some of these AI systems work and some don't work in the real world deployment? That's my motivation question that motivate myself and my lab's whole research agenda. So if we look back, in order to find the answer to that question, let's look back, look at the history of AI. So my friend, mentor, Jonathan Gordon, who's a Microsoft research colleague, he looked at the application counts, the students enrollment in different ACM chapters, as well as the angel fund, the investors' money, right? By counting on these 3 quantitative numbers, he plotted this clear up and down trends of AI. He calls it AI summer and AI winter. And we are clearly seeing different patterns, and we are now on the 5th wave of AI summer, right? This failure of IBM Watson Health happened roughly 2019, 2020, right? But this is not the first time in human history or in our society that we had this wonderful idea of building some AI algorithm or a program to help human doctors to make a decision. So 2 cycles back in the UK, there's a government research agency called Applied Psychology Unit, APU. They had exactly the same idea, but also failed in 1988. Healthcare is not the only highly investigated domain, but also lots of failure. Another heavily invested domain or industry sector is called smart intelligent agent. Right? So roughly 5-6 years ago, 6-7 years ago, chatbot became a thing, right? So it all came from because of the Microsoft Xiao's system success in the Asian countries. And then only took 1 year, like all the companies, startups suddenly realized that all the chatbots fail, right? So it took them 1 year to turn around to that sentiment. Again, we're repeating ourselves, right? 1 cycle back, roughly in 1997, Microsoft had this wonderful idea of injecting some AI system on top of their Microsoft Office suite. They called it Clippy. This is one of the most famous or infamous example in HCI UI UX design. Even the designers and the engineers who built this, they acknowledge that's a total disaster. Right? So what they did is basically they created this cartoonish face on top of the Microsoft Word, PowerPoint, all these things. And then when the user starts typing in something, they try to infer what user is doing, right? Since you are writing a letter, do you know we have a letter template? And then they guide the user to that particular button. It's for feature discovery purpose. Now we have Copilot, right? So again, like the user needs are always there, and history are always repeating itself. So maybe the Office Clippy story is a way before many of the audiences sitting in this room, 1997, right? Some of you were not even born. But we should all remember the Microsoft Tay example, right? So this was the migration of the Asian countries' Xiao S chatbot success story. But then Microsoft research here deployed it into the Twitter platform. It was a social chit chat chatbot. It can respond to Twitter users kind of like response or retweet, but it took the system less than 24 hours to turn from a social chit chat friendly chatbot to become a pro-Nazi, anti-social, anti-human kind of like a system. So what really happened there, right? So Microsoft had to take it down, and they never put it back. I'm not criticizing all my friends and colleagues from different companies, right? Ourselves, roughly in 2016, 2017, we also built this now look like a very stupid example of putting a conversational-based intelligent teammates into a group discussion meeting so that it can help with the decision making. So let me play this video. So this is also a failure, just so you know.
Should we be able to hear something? Because we can't.
Oh, you can't?
No.
Probably I should make the sound a little bit bigger, so maybe it can be captured by the microphone. Okay.
I think Zoom requires you to select sound. I don't remember where it is. You can do it when you're in, but I don't remember where it is.
Got it. Yes. So I'm selecting the same sound. It's supposed to be there, but we'll try when the next video come up, right? So roughly speaking, if you pay close attention, we were trying to control the eye contact and the facial kind of like orientation back in 2016, 2017. Why this is a disaster or a failure? Because we were motivated by the speech recognition algorithm introduced by our friends, colleagues, teams. They were telling us their accuracy rate has reached 95%. So that's why, we have a great AI algorithm. Let's try to find the nail for this hammer. And the nail is like, what about a team like avatar like function or system that can support the team discussion? Right? In reality, many engineering kind of like errors or challenges appeared, and no user want to use it. So that's a different story. Okay. So back to my leading example. So that's the IBM Watson example, right? So IEEE magazine, they had a very nicely like a story, try to decipher what happened behind the scene. I don't fully agree with all the rationales reported in that article, but the cover image, this illustrative image, I think is conveying a very important common root cause why many of these AI systems fail in the real world. Sometimes our designers, engineers are intentionally or unintentionally trying to design the AI system to replace replacing a human doctor's brain, replacing a human colleague's functionality. That's fundamentally wrong. This take or this argument is supported by our CHI 2020 paper. The interviewees that we ask, the clinicians, right? They directly ask us this question: are you designing AI to replace us, to replace human clinicians, right? So of course we are not, but the perception that our system are giving our target user, as long as our target user start to ask this question, no wonder why they don't want to use your system, and then your system are being abandoned. It's not that our target user don't welcome AI systems. It's just they don't want that particular type of AI systems that's trying to replace them. So what they really ask for is an expandable, trustworthy, and cooperative AI system, so that the AI system and the human can form a human AI collaboration. That's what they are asking for. So I think we have a potential answer, one possible answer to this motivation question. Why do some AI systems work or fail in the real world? The potential answer is this human AI collaboration future. In summary, I want to say like our human AI collaboration future is that we want to design these human-centered AI systems as collaborators rather than competitors to humans, so that the human AI teams can complete the human task better, faster, while being integrated into the real-world workflow and context. So I want to put a note here, right? When I say human AI teams or human AI collaborators, we don't need the AI system to always have an avatar face or robotic represents or embodiment. Sometimes they could be invisible, right? That AI system could be invisible. All it matters is the focus is on the human task, human existing task, human needs. And then the evaluation should be those evaluation matrices so that the human tasks are already using productivity, right, quality, and the final outcome. And then we should always respect the real world workflow, existing workflow and existing context. Don't try to put more burden to human, right? That's also a common mistake that when we design these AI systems. So human AI collaboration, in my opinion, is a philosophy, ultimate design goal, but also is a UI UX design paradigm. And it provides design patterns and actionable frameworks and metrics that we can do, right? How to achieve that? I think one way that we can achieve human AI collaboration, this ultimate goal and philosophy, is to learn from our existing knowledge of human collaboration and the human AI team. We have 2 centuries, right, 200 years of literature. People are studying, reporting, and digesting theories and frameworks to talk about, depict the human collaboration. My advisor, Judy Elson, who's really famous for his framework of depicting what are the common dimensions of that we should consider if we want to have a successful human-human remote team collaboration. In summary, she depicted these 4 dimensions: coupling of work, common ground, collaboration readiness, and technology readiness. For example, coupling of work is talking about the work that some works require a more closely collaboration nature. Some of the works requires a loose collaborative nature, right? So that's the nature of the work. They are different. Common ground is really talking about before you start the team collaboration, every person should be aware of whose responsibility on what task was the final goal. And then during the process, the common ground should be continually built and maintained so that everyone knows what others are doing. And all these work are summarized and presented in this classic paper on these matters. Now we are talking about human AI collaboration, right? So we heard lots of these sexy terms of human in the loop, expandable AI, trustworthy AI, AI literacy. But fundamentally, if you think about it, human in the loop is really trying to say where AI and human should interact inside a particular workflow of the work. Right? We need to first analyze and understand what's the workflow, what's the nature of the work, and then we start to find the best place to fit the AI into it. Common ground, right? Talking about it, each other within a team should be aware of what others are doing and what's each other's intent of the next step of work, right? That's expandable AI. That's by definition expandable AI. So that's why I think we have some theoretical foundation that can help us, guide us to design this AI system to reach human AI collaboration. Right? So we have a noble goal, ultimate goal, North Star of designing AI system. We have some theoretical foundation and a framework to guide us how to design. But still, why don't we have it in many of today's AI system building? I think we need one more thing, one more space in this whole cuisine, which is interdisciplinary team. So if you look at the people who today are working in or researching, developing this human-centered AI research and product agenda, right? We see clearly two different communities. One community they call the machine learning, deep learning technical community. They focus too much on state-of-the-art model performance. Sometimes they work on interpretability and explainability features or fairness features or agenda. But their solution to those explainability problem is that you have a 7 billion large language model. I have a 400 million parameter kind of like a smaller model. So my model is more interpretable, explainable than your model. But that's, in my opinion, wrong, right? So no user can interpret that 400 million model anyway. There's another group of people in our community, mostly myself included as well. We were trained as human researchers, user researchers. We focus a lot on proposing one after another design guidelines. We propose what's the button color, shape, layout should be look like for that UI feature. Some of us are also interested in trustworthy and the societal impacts of this AI system, but most of the time, only after that AI system have already been implemented and deployed into the real world. So the damage has already been made, and then we study from the post-fact and perspective. What I believe, in order to make this human designing and building human-centered AI systems for human-AI collaboration, we really need to focus on these two edges. At the top, we need to make sure that the human knowledge digest, understand, study the proposal by the HCI researchers, user study researchers, that can pass on to the machine learning community. But the machine learning community, they would never come to read our CHI papers, social science papers, right? How can we do that? We have to translate those knowledge into a language that they can understand. The language they understand are new data sets, tasks, benchmarks, right? Model designs. These are the language that they can understand. And then we publish in the places that they would actually read. NeurIPS, ACMs, AAAI, like these are the conferences and the application venue they read. Okay? In such a way, the machine learning community, they're our friends, they're our colleagues. They can actually work on these more towards the real world problems and the data sets to abandon their toy examples. Right? It's our moral duty to introduce those knowledge and the task to the ML community. At the bottom of this chart, right, find the advance of the AI technology, right? You may have heard about the RAG, you may have heard about the large language model, you may have heard about transformer, right? That algorithm, that technique is not usable by our human world. It's not usable by our target user. We, again, hold a moral duty to help them wrap those AI algorithms, make them to become like human-centered AI system and interfaces. These systems, not the algorithm, can actually serve as the interface between the human intelligence world and the machine intelligence world. Now, it's our duty, it's our job to bridge that gap. So I want to spend maybe roughly next 10 minutes to give you two quick examples of how we can achieve that. Right? So these are two case studies. In the first case study, I want to illustrate the application domain is data science. The second study is AI for education. And then I want to reserve the final 10, 15 minutes to talk about the future, right? What we are working on, what I believe could be the exciting future opportunities, okay? So let's quickly start with these two case studies. The number one is, the first case study is data science, in the data science domain. So my research team, my colleagues, we studied all kinds of like human data science teams workflow in non-profit organizations, in data hackathons, in schools, in for-profit, large for-profit, government sectors. all kinds of settings, right? By studying, understanding how human data science teams work, we can digest, extract this common data science workflow. We call it data science life cycle. From the very beginning, right? So the whole project starts with a problem formulation, then move into the data-driven task like data cleaning, data EDA, right? And then going into model building, model training, and the model deployment, and finally decision making, right? That's the workflow that humans are following. We also identify who are the stakeholders, like and then that are collaborating and working, and then we align them, align the work stakeholders along this workflow at the different stages of workflow, so that we know who's talking to whom, what are the artifacts that they are exchanging, right? How they are maintaining common ground, what's the collaboration awareness, who may be able to talk both the technical language and the business language so that they can serve as the broker, right, to perform the brokering activity. Some of the data sets, some of the code or notebook can serve as the boundary object, right? All these terms, stakeholders, right? These are social science theories that we can use to describe human activity. Then we can start to focus on what are the AI technology, what are the AI capabilities available to help us build this solution. So the particular technology we're focusing on here is called AutoML, Automated Machine Learning, or some people call it NAS, Neural Architecture Search. So that was the algorithm back in 2020, 2021, super popular. And then this is the system that we built, wrapping that algorithm to support the stakeholders that we have. Let me play this a quick video.
If there's speaking happening, we're not hearing it still.
For deployment. So I changed the speaker, so next time definitely it should be better. Thank you so much, Suzanne. Okay, so yes. How we build it, right? Basically, we lay out the human data science workflow, and then we start to build those algorithms, right? Each of those color box is a piece of algorithm, and then we put them together. The way that we design the user interface, so where user can interact with our system, is trying to follow how different humans are exchanging information and hand over code or data, right? So due to time, I will just quickly skip all these nitty-gritty details, like a code generation. So we had this wonderful idea of automatically generating Jupyter Notebook code directly from the AI result back in 1980 and 1918 and 2019, 2018, and later we all know that Copilot has this functionality, very successful, right? So using this study, all I want to illustrate is that the human collaboration theories and concepts, those like brokering activity, boundary object thing, can really be helpful and guide our design and research of building successful human AI systems. So the theories, the CSW theories, the social science theories that we learn are our powerful weapon to guide the design in this AI era. So the second case study, I think I need to be very quick. Roughly speaking, I want to illustrate how we can build an interactive collaboration team, collaborating with learning science researchers and then machine learning algorithm researchers and HCI researchers, social science researchers, all together to build a research project, and very effective and very impactful. So, but as a beginning, let me show this demo video first.
In the automated bot reading mode where the parent is absent, Story Buddy allows the parent to select a book, preview the generated questions, select the ones to use, and customize the bot-child interaction in advance. After the parent configuration is finished, Story Buddy is able to read the book, facilitate interactive question answering through a conversational bot without the parent's intervention.
Okay. So this is a story body system that we published in 2022. Why did we build it? Right. So as I said, we collaborated with the learning science researchers. Back then, learning science research had this wonderful idea of, during the pandemic, kids are grounded at home and parents are working from home, but the kids needs a lot of attention, right? Can we provide an AI system to help the parent-kid story reading activity at home? Starting with that idea, we recruited 120 kids aged between 3 to 6 years old. And then we divided them into 4 groups. It's a 2x2 between subject design. The fundamental, we ask both the human adults and the AI system to read the same storybook and then ask the same set of questions. And then at the end, we evaluate how much book content that the kid actually understand. So here is a study session.
There's Greg.
Wow, beautiful blue seashell from the sea.
That is correct. What did the bears break?
Okay, so we run 120 of those book sessions, right? And then we measured lots of things. But the one particular thing I want to share here is the book comprehension outcome. This is measured by a preset of 10 questions after they finish reading the book, right? What you're seeing here basically clearly, right? So this static analysis is telling us no matter whether it's a human of course, human reading the book is always better than the AI reading the book, but that's not significant, right? And that's significant. What's significant is while you're reading the book, do you have the interactive dialogue or not, right? So this is significantly better for kids to learn language skills, to understand the book, to memorize the book. This gave us confidence, say like, oh, we need to build some of these AI solutions, right? At least it's better than nothing, right? So that's why we start to work on this product. But technically, back then, there are 2 challenges. Number one, we need to have an educational expert that can translate or transcribe each of these static book into such a data structure called the dialogue flow. So that requires manual work from the domain expert. Secondly, whether you are developing it, deploying it into a Google Home, Amazon Alexa, or Apple Siri kind of like system, you need a team of engineers to manually implement it, right? It's not manageable, scalable. Our proposal is very simple. We want to translate or transform any of this static book into an interactive reading experience. But if you decompose that vision, actually, we need a data set. We need an algorithm. We need a system, right? We need the final UI design. That's how the whole team formulate and together during 3-4 months of time, we published 4 top tier papers in different domains, right? That's the system demo that I showed at the very beginning. This is the place where I called it translating human knowledge, real world requirement into the machine learning community's language and knowledge, right? So we create a data set by recruiting educational experts. So when they create the data set, right, they need to balance the implicit, explicit answers. They need to balance the different type of questions. These are all following the learning science literature theory to say, oh, if you balance all these 7 type of questions, the kids can learn better. right? We also compare this data set with the existing data set. We build models as benchmarks, right? Because once we put this like 0.65, 0.53 number out there, suddenly the whole machine learning community, NLP community become our friends. They will help us to invent all those state-of-art algorithms so that we can integrate their algorithm into the system and serve our target user. But because we are the first group of people who have access to this data set ourselves, we can also create a new model architecture and train algorithm and publish the work in the NLP conference, right? Our system can significantly beat the state-of-art models back then. Okay? And then in the system design, right? What we want to make sure we are following the human-centered AI design philosophy. We're not designing this system to replace parents. Rather, we say, parents, you understand your kids the best. You understand what books your kids want to read and what kind of questions fits the kids' needs the best. So why not, like, we gave this UI to the parents, right? So if they like the question generated by AI, they can select it. If they don't like it, they don't select it. Or even better, right? If they have their own question and answer, they want the book to interact with the kids, they can click that edit button, write down their own question and answer. And once they're happy, they click this deploy button. And then the whole interaction can become fully automated. The kid, 3 to 6 year old kid, they don't know how to read that well. So they click on this play button. This paragraph will be read out. The green box will also be read out. And then they click this microphone button, and then they say the answer, and then this green box will be read out. So that's purely voice-based interaction. Okay. We conduct a follow-up user evaluation, and this is the parent-kid interaction session. Lots of interesting findings, but after all, if you're interested, read the paper. So using this project, I'm demonstrating how we can formulate an interdisciplinary research team to conduct this full cycle of closing the human-centered AI research loop so that we can build these successful AI systems to support human-AI collaboration in the real world. Okay. I know many of you may have many questions. Let's hold your question till the end because the final part, future work, this is the most exciting thing. I think given nowadays, large language model, ChatGPT are dominating the research community, the tech community. Given that we have so many these state-of-the-art large language models, ChatGPT, GPT-4, 4.0, 0.1, right? So Llama, Cloud, every day there are new opportunities, new technology coming out. But all of these kind of AI systems, models, they are imperfect. What I mean by imperfect AI system is they are not AGI. They are not artificial general intelligence. If they are perfect, then basically we don't need to spend much effort in designing the interaction. Sometimes they still make mistakes. They still have a hallucination, right? There are still boundary cases those generically available system cannot do. So that's what I refer them as imperfect AI system. However, my position is that we should not wait. Let's not wait for another 5, 10, 50 years until the perfect AI system, perfect AI algorithm become available. We need to design those functional and usable AI systems with these imperfect AI algorithm. Okay, there are two particular challenges as I see as of today. One challenge is different tasks has their domain specificity. Second challenge is we have more and more non-technical users who do not know how to write code. They do not know how to write a sophisticated prompt, right? Very complex prompt. So that's the two challenges, and also the two opportunities for everyone in this room. In order to solve the first challenge, right? Well, first of all, why domain specificity is important. So many of you know, like a large language model, GPT-4 kind of model, they have roughly 300 billion or 400 billion kind of like parameters, right? But if you have the domain specific task, domain specific data, you can fine tune a very small large language model, like a 7 billion large language model. The 7 billion large language model can outperform the generic task in this specific domain. That's the power of data in a specific domain task, right? Because of that, why is that? It's because of the prompt engineering, like the context of that long prompt is not enough to ground or control the generic large language model to pay enough attention or focus on that specific domain. So data is still very powerful, okay? So now we know the problem. What are the potential solutions? So I propose two solutions. Number one, it's not about the AI algorithm. It's about the AI systems architecture. So I propose AI in the loop system architecture. What is AI in the loop system architecture? Many of you are familiar with the human in the loop system architecture, but if you think about the human in the loop system architecture, right? Typically, people are referring to two places where humans need to be in the loop. One is in the model training stage where we don't have enough data. So we use human as data slaves to label more data so that we can improve the model training. And then once the model performance is good, we don't need human anymore. Another place where we typically refer to human in the loop is during the model deployment stage. It's because our AI algorithm doesn't have a good performance accuracy, right? Once it has a generation, we worry that prediction may be below a certain threshold of the performance. So we need a human as AI slave there to make sure that that bad prediction don't go into the downstream application. So human can serve as a supervisor, monitor, and a revisor for those AI prediction. It works fine in some scenarios. That's why human in the loop is such a profound idea, right? Because it's better than human, it's better than AI alone. But it doesn't work when you move into those high domain specificity scenarios, because our target users are teachers, doctors, lawyers. They are very well paid and they don't want to be data slaves or AI slaves, right? You have to find a way to make AI can work together with those people without grabbing them or dragging them out of their daily routine. That's why we propose this AI in the loop idea. So the AI in the loop idea is that if humans are already doing some task, right? So they have that data, right? They look at the data, they make their own decision, right? Keep them doing what they're doing, right? Don't disrupt their existing workflow. However, right, we implicitly capture the user action, user behavior, right? And then translate those user action, user behavior as feedback. This is called weak supervision data labeling, right? Transform those feedback to feed into our model and iterate the model so that the model can learn implicitly and quietly behind the scene from the user interacting with the system that they are already doing. And then only when the system are feeling confident enough, right, it make a prediction. But that prediction should not interrupt or disrupt the human's decision-making, right? We should have a very subtle kind of overlay of that AI prediction on top of what the human may want to see. And then it may actually work together with human. There are many of these recent works talking about the human AI appropriate alignments and appropriate decision making. And in our own work, we looked into medical decision making called sepsis decision making. It actually works. Due to the time, I won't go too much into details. Other than the AI in the loop architecture, right? There's another solution, which is techniques behind this architecture. So these are things like fine-tuning, supervised fine-tuning SFT, large language models. I have illustrated in this mental health context. It works very well as long as you have more than, let's say, 10K of training data within a particular domain. You can beat the generic large language model GPT-4 4.0, okay? Another technique we can do is called active learning or reinforcement learning. That's when you have some amount of data, but not a lot of data. So you still want to, you still have the GPU resource to train the model. So you can consider active learning. If you have a lot of data, lots of GPU, then go with a supervised fine tuning. Okay. Number three, if you really have limited data points, you don't have GPU, then you cannot alternate the model's parameter. What we can do, we do in-context learning, right? But then in this particular paper, authors, NACO 2024 paper, the beauty is not only at the how you craft the prompt, but also how you select the example that you put into that prompt. Okay, so select the most represented example, select the positive case and the negative cases, put them into it, and randomly shuffling the example that you're adding into it. That's how we can maximize the effectiveness of using in-context learning. Number four, RAG, retrieval augmented generation. So in some of our work, right, we already have this structured data base have already exist in Wikipedia or in Department of Education. They have this a next generation science protocol. How can you identify the most relevant knowledge from the structured database, inject it into the prompt, and then send it into the learning model so that the final generation, conversation generation, can be related or grounded into that particular context. That's RAG. It's very effective and also a popular technique. Everyone should get familiar with. Lastly, number five, is also a very novel technique called LLM agents, LLM generated agent. Roughly speaking, you give a user persona, ask it to generate things like user behaviors, like, oh, your browser activity, like what you're looking, what you are browsing. And then you can use that to fulfill certain tasks. So I want to show you a demo where we generate thousands of agents to test a web page. And then we can provide those qualitative and quantitative log to UX researchers so that UX researcher can use those initial feedback to revise their UI design as well as revise their user study design. So here's a quick demo.
In this demo section, pretend you are evaluating a new design. You are watching an automatically recorded session of replaying one virtual customer's full interaction history. From it enters the first query into the search box, to clicks on refinements in the filter menu, to the final purchase decision. The virtual customer first clicked on the detailed tongue brushes filter refinement under the oral care products department filter, didn't find what they want, so it then clicked on the broader oral care products department filter, and also the 4-star or plus filter. Even more, at the back end, we know exactly how these virtual customers think and feel.
Okay, so what you just watched is an automatically recorded session, like shopping session, fully driven by a large language model agent, right? This terminal is showing the reasoning behind each of those actions. Okay. And then even more, what we can do, right? So after you have thousands of these virtual customers tested, you can conduct a qualitative interview, ask them why they did that. Oh, if I have a new UI design, will you like this or that better? Right?
In this demo session, you can conduct a post-study interview with each virtual customer to gather more qualitative feedback on their shopping experience. For example, the virtual customer clicked on the 4 stars and up filter, and you may ask them, why is that important to them? You can also interview virtual customers to ask them to give early feedback on future designs before investing resources to fully develop it. For example, the virtual customer didn't exactly understand the number of traveler drop-down box and found it confusing.
Okay, so
in this demo section, you can conduct.
So these are the state-of-art AI techniques that are being bragged and reported in the ML community. I was showing you the UI UX, like online customer shopping experience, but you can also migrate this idea to focus on, for example, older adults' health behavior simulation so that you can invent some intervention with respect to their individual calendar activity and heart rate, right, the multimodality, all kinds of things. It opens lots of opportunity. Finally, I want to show the second challenge that we have, or the opportunity that we have, is that given this larger model are more and more powerful, we are reaching the user population that in the past we would never reach, right? Older adults, younger kids, right? They are the target audience that are now being empowered and democratized by this kind of technology. But they would never come to a web browser, like OpenAI, ChatGPT web browser, type in that query. We need to think about what are the natural user interfaces these marginal underserved customers, user population may want to see. In one line of our work, we're developing this model system architecture to put learning model capability into a smart speaker so that the older adults at home can talk with this smart speaker to provide daily health symptom check-in, and then it can automatically sync into their EHR system. So here's the final demo system.
Alexa, open Recover Bot.
Hello, this is the Recover Research Study chatbot. Are you ready to start today's questions?
Yes, I'm ready.
Great to hear. Is there any specific discomfort or symptom that's been bothering you today?
I have some pain in my stomach, and I'm taking Tylenol number 3 for the pain.
I am sorry that you are experiencing pain. Can you tell me more about when this pain started? And on a scale of 1 to 10, with 10 being the worst possible, how would you rate your pain?
It started around 3 hours ago, and I would rate it maybe 3 out of 10.
Thank you for sharing that. Since you mentioned taking Tylenol number 3, are you finding any relief with the medication? And is the pain steady or does it come in waves?
Yes, the Tylenol does help, and yes, the pain is steady.
So I don't want to finish the whole demo, but as you can see, in comparison to today's general conversational agent system, the user can provide multiple information in one utterance, and the agent or the conversational agent can remember those, right? So user said, I took Tylenol number 3. Also, I had the pain is 3 to 4, right? So that's the beauty of using today's learning model. And then this is the dashboard, right? So we simultaneously record all those unstructured data into this conversation log, and then we use model to automatically extract them into the structured data format, because this kind of data structure format is what the doctors really want to see, and they want to sync into their EHR system. And then that particular patient or user mentioned breathing, but no problem with breathing, so that's green. Mentioned pain, there's some pain, so that's red. They didn't mention anything else, so that's why all the other are gray color. You can take this idea to even more wild environments, right? So what I just showed you is a smart speaker, but you can also put this into virtual reality environments. So we have these demos, but I don't think I have time to show it. Let me go to the closing page. So in this talk, what I want to introduce is human-centered AI. I think is the way to move forward to make those imperfect AI algorithm to become usable AI system. And the design goal and the design framework paradigm should be human AI collaboration. That's one possible solution to resolve the massive failures of the AI system deployment in the real world. In order to achieve that, we need to have an interdisciplinary research team. We need to collaborate across the different communities. We need to work at the top and the bottom, the two edges. With that, I would like to conclude my talk. Thank you so much for joining us today. Where's the light? I'm happy to take questions. maybe you can just, if you have question, just stand up and shout out, or if you're online audience, just raise your hand or unmute yourself. Okay, this one. Wait, this one works, yes.
Hello. Hi, Dr. Thank you for the presentation.
Yes.
I had a question in the slide where you showed the LLM agent, where it was interacting with the Amazon website. How were you able to ensure that they weren't just random simulations, but the LLM agent was actually adapting the persona that it showcased?
Right. So thank you so much for the question. So the question basically is asking, right, so the generic LLM, which we're using, right, the GPT-4 model, how can we ensure that when we simulate it 1,000 times, it has the variance that are consistent with the particular persona that we are giving it, right? So this is a great question. So for now, based on our experiment and evaluation, we can see there are differences across different individuals. Basically, in a paper that has been submitted but yet to be published, a paper that we can see there are differences across different individuals. And then within that specific individual, right? Because when we write the prompt, every time we're giving it the persona, as well as the track record, the history of the actions and the reasoning, right? That's how we can make sure that every individual agent can still be consistent with its own persona. However, there's a caveat, and that's a very exciting and interesting research problem that hasn't been solved by anyone. It's the fidelity. How do we know that the agent that we generated saying, 18 years old college student with an income of $2,000, like or money $2,000 per month, is actually aligned or consistent with a real human that would perform in such a way? There's no one has solved that problem. We don't have the data, but that's something that we are really interested in. Like, for example, recruit maybe 100, 200 of those users, ask them to use Amazon Shopping and then keep track of their behavior and collect their user persona. After that, we have a evaluation data set, and then we can start to evaluate. Because as of today, in the world, there's no people can answer that question. But thank you so much.
Great thought. Question on your Amazon Alexa demo for, I guess, capturing some health symptoms. How is that? How do different LLMs work with this particular demo?
Yes.
Do you need a very specific LLM to drive that?
No, no. So in order to implement this study, right? So we tried out like most of the available LLMs. What you just saw was Claude 3.5. So, but before the new like a computer use version of that Claude, right? So based on our testing, GPT-4 4.0 performs the best. GPT-4 performs the best. 0.1, the OpenAI 0.1 doesn't have much improvement. Sometimes it makes stupid mistakes because it's mostly for reasoning, not necessarily for understanding the UI, the HTML kind of like a web page. Claude 3.5 performs slightly worse than GPT 4.0, but with some prompt engineering, you can reach a reasonable performance. Llama 3.2 without fine-tuning is not that reasonable. So I think out of 100 sessions, like percentage-wise, out of 100 simulation, roughly 8 or 9 would fail if you use Llama 3.2. However, because Llama 3.2 is the only open source model that we can fine tune, right? If we have enough real world, real human behavior, we believe that's the chance that we can fine tune, and then it should outperform all the other larger but closed source language models. Thank you.
I have a question online.
Oh, so one more in the room and then online. Okay. Yes.
My secretary who will keep mine. Thank you for this talk. I really liked the Jonathan Gruden plot you had there. I think what's interesting to note about that is that you're plotting kind of like the rise in interest and then fall in interest, but those are also kind of like highlighting technical advances that are enabling us to do more and more. Yeah,
yes.
Exactly. And I found it interesting in the beginning you were talking about with the clinicians, the goal wasn't necessarily to replace them.
Mm-hmm.
At the end of the talk, what was interesting was that I think you were using the elements to replace them.
Yeah.
So like you were using it to replace users with testing, automated testing. And then with the help assistant, it was like using an element to kind of act as an actual virtual assistant. So how should we think about human AI collaboration in light of these trends where the models are becoming more and more capable, where it's not too difficult to imagine a future where the models are superior to your average clinician, as an example.
Got it. Thank you so much for your question. So I'm waiting for that question. That's the gem I hide in the talk, right? So that's conflict and the tension between the beginning and the end. So to directly answer your question, right, that LM simulated agent is not to replace the like general user. It's because we want to protect the human user. I'm not suggesting, or I would really argue against replacing the real human like evaluation user study with this kind of like a simulated settings. However, if you think about today's user evaluation, heuristic testing with users, right? Sometimes you need to run a pilot test. Well, most of our study, we need to have that pilot session. But the pilot session is one with one user, with two users. Try to expose the bad design or harmful like a study design or feature design. I believe the automated simulation using those agents is actually to expose those bad design and harmful design or useless design before we run the real human testing. That real human testing, real human user testing is still necessary. But this, we can give the designer more, more safe net to help them iterate their design before they actually run the user study. It's actually to protect the UX researcher, UI designers' time and resource, also to protect those real-world customers' benefit. So as I said, I'm also affiliated with Amazon now, right? So I'm not allowed to disclose how many A/B tests like Amazon is running every day, how many billion of user sessions that are actually going into that treatment condition, and what's the small percentage of successful UI. Basically, if the user are going into a treatment session and they are not getting the benefit, or the result are not showing positive gain, they are experiencing a worse than normal kind of like session. So the simulated environment that we're running here is trying to reduce those users who are experiencing the worse than normal UI design. So that will be my position. Yeah. Thank you. Let's take one question from online. Dan, as your hand is on.
Thanks. Thank you for sharing this work. So I'm wondering if you've looked at literature on unintended negative consequences of human AI interaction and how that's informed your approach. And just to illustrate that, a couple examples are studies on how human AI interaction can displace opportunities for skill development, whether that's for children or adults. Other ways in which it displaces human-to-human interaction in the home or the workplace. And a third is potential economic repercussions for workers when there is technology that is not only designed to make them more efficient.
Thank you so much, Dan, for the question. So, I think my answer to that question has two points or two remarks. Number one, I think so the system that we're designing or the AI system we're designing, I never believe it like AI will replace human. So that's my fundamental kind of position. I don't want to build AI to replace human. I don't believe AI will replace human. However, I do believe human who embrace and use AI will replace those human or outperform those human who are resistant to AI. So it's really like, AI are empowering some human to become more productive and to do their work better, faster, and then will cause some job disappear. But there will also be new job opportunities created by these AI systems. It's just we are still closely monitoring the data. We don't know what's going to happen once these AI systems or techniques are becoming more and more integrated into the different industry sectors. All we can see nowadays is that from Silicon Valley, the IT industry, computer scientists, SDE, software development engineer, SDE, data scientists are losing their jobs, right? And AI researchers, ML engineers are, really in huge demand. There are not enough people supply for those job opportunities. So the IT industry is experiencing a shift. If you look at the job opportunities and the posts on LinkedIn and on those kind of like news outlets. So that's to answer your first question, whether AI will replace human or human will replace human kind of like point. The second thing is what's the potential unintended harm, right, of using this AI? How would it maybe harm a particular like a vulnerable population? So I happen to have a study. So this is analyzing the fairy tale storybooks. If you think about Snow White, right, so the most famous kind of like a fairy tale storybook has been read by different countries, no matter what's the cultural dynamic you're reading, right? The female character, Snow White, the princess, are always weak, right? They eat something, poison apple, they die, or they grow apart of horns, they start crying, they are caged in a dungeon. They have to cry, and ask for help until there's a male character appear, kill the dragon, save them, and then become, or the two together got married and live happy ever after. If I have a baby girl, I don't want that baby girl to learn from that role model, Snow White, to stay weak and wait until someone to save them. But these storybooks have those hidden stereotypes and social biases that has been taught, read from generation to generation. Using this AI technology, we are not really, and together with the community and my friends and colleagues who are working on fairness AI, we're not really, creating those unintended damages or harm to the human. Rather, we are actually leveraging AI, try to expose and identify those existing social biases and stereotypes, and trying to find a solution that can solve them and solve them at a scale. So I think it's always a challenge for us, but it really depends on the people like us in this room and in the audience who are studying them, who are researching them, who are designing them, who are building a system around them. Right? So as long as our philosophy is towards human-centered future, right, is for humans' benefit or for a better society, right? The sword is in our hands. It's our duty and the moral responsibility to know what the technology can do, what the technology cannot do, and use them for the better society, for the better future. So I think that's my answer to your question, the second part, which is, I don't have an answer, but I think the answer is in the hand of every one of us. Thank you, Dan.